Okay, we're going to do our third practice quest. So it is actually called PreQuiz number 2. And remember that this is exactly what our quiz is going to look like. So here we go. Number 1 says identify the sequence. So we take a look at that sequence. Let's see. It doesn't look like we're adding the same number because 1 plus 1 is 2, but 2 plus 1 isn't 6. So we're not adding the same number. It also doesn't look like we're multiplying by the same number because 1 times 2 is 2, but 2 times 2 isn't 6. So A is a neither. And actually, A is a special set of numbers. This is just an aside. This has nothing to do with arithmetic or geometric. This sequence is not arithmetic or geometric, but it is special. The numbers are actually the factorials. 1 factorial is 1, 2 factorial is 2. Remember, factorial means start with that number and multiply down, so that's 6. So 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, and so on. So number A happens to be the factorials, but it is not arithmetic or geometric. All right, what about B? Well, I hope you can tell just by looking that it is not arithmetic. You're not adding the same number. I wonder if we are multiplying. Let's see if we are multiplying. So the set of numbers is 5, 4, 16/5, 64 25ths. If I'm looking at these last two, it looks like I'm multiplying the top by 4 and the bottom by 5. Well, what happens if I do the same thing with this one? If I multiply the top by 4 and the bottom by 5, do I get this? I do. And if I multiply this by 4 over 5, I get this. So this is geometric, and my ratio is 4/5. Remember, you can always, always, always compare second to first, so 4 over 5, and then third to second, and some of you aren't going to like this because it's, a complex fraction, but if these two match, if second divided by first is the same as third divided by second, then you know you're geometric, and whatever that equals, that is your ratio. All right. And the last one, see what's happening there. It looks like we're going down by 8. So it's arithmetic, and the difference is -8. Remember, in almost every problem we do, the first thing we have to decide is if we're arithmetic or geometric, because that's how we're going to know which formula to use. All right, so number 2A. Find A sub 2015. Well, we know we're going to use one of our A formulas. Which one are we going to use? Well, let's look at the sequence. What's happening in the set of numbers 2, 5, 8? We're going up by 3, so it's arithmetic, and the difference is 3. So since it's arithmetic, we're going to be using this formula right here. This is my arithmetic formula. So that formula says take the first term, which is 2, add the common difference, which is 3, we figured that out, and then remember that n and that n are the same. So if that's 2015, this is going to be 2014. So I take my calculator out. And it looks like 6,044 is the answer to that question. To B, I'm finding the sum of this set of numbers. Well, the first thing I need to do is figure out what kind of numbers they are. Wait a second. See that right there? There's no number down here. There's no sub number down here. So the only formula that's an option for me is this guy right here. Well, what do I need to know? To use this formula, which is the only option I have, can't use these because I don't have a sub. That one right there. I need to know the first term. The first term is 4. And then I need to know my common ratio. So how am I getting from term to term? Look carefully. Look at those last two, especially. It's real easy to tell kids, to get from here to here, we have to multiply the top by 3 and the bottom by 4. So our ratio is 3/4. Well, 1 minus 3/4 is 1/4, or 0.25. Remember, you can use your calculator. So the answer is 16. So somehow you've got to come up with 16 as your answer. So however you're doing it, fractionally or decimally, make sure you're getting 16 as the answer. All right, next one we're finding a sub 13. So we're going to use one of our a formulas. What's happening in this sequence in letter C, 2C? What's happening? Looks like we are multiplying by 2. So my ratio is 2. So the 13th term, if I'm doing a ratio, I'm using a geometric sequence. So the 13th term is the first term times the ratio to the n minus first. Remember, these n's are the same. So if that's 13, this is going to be 12. Type that in on my calculator and make sure you should be typing this in with me. You should get 24,576. If you're not getting that number, please make sure that you try it again until you do. Okay, D, find the sum of 213 terms. So I'm going to be using one of these formulas because it's S sub something. So the sum of 213 terms. Okay, well, is it arithmetic or geometric? Look at that set of numbers. What seems to be happening in that set of numbers? Well, it looks like I'm going down by 10. So that means it's arithmetic, and the common difference is -10. So my arithmetic formula is down here. Can't be this one, guys. R is ratio. That's geometric. This is your arithmetic formula down here, Ross's little formula, right here. So 213 over 2. The first term is 1,000. Oh no, this happened to us before. I need to add the 213th term. That's what the formula says, a sub 213. And I do not know what that is. I don't know that number. In my sequence, I know I'm going down by 10s, but I need to go down by 10s until I get out here to the 213th one. I do not want to count down by 10s to 213. So what I need to do is find that. Well, this is a problem within a problem now, because I need another formula to find a sub 213. So a sub 213 is the first term, which is 1,000, plus the common difference, which we already said was -10, we're going down by 10s, times n minus 1. Well, remember n is 213, so that's going to be 212. I'm going to figure out what that is. And I got negative 1120. So negative 1,120 is the 213th term, the last term in the sequence. So now I have to evaluate this, which I can do. So parentheses, and times 213 divided by 2. My final answer to that is negative 12,780. That is the answer to letter D. D. So that was a two-stepper. We've had that before. If we don't have the number that we need, we use the other formula to find the number that we need, and then we put that in, and we're all set. Perfect, perfect, perfect. Okay, letter E is another sum. We're going to be finding a sum for letter E. The sum of 8. Alright, so I'm one of these guys down here. What's happening in the sequence? It looks like we are multiplying by 3. So my ratio is 3, which means I'm going to be using this formula right here. This is my geometric formula. So let's see, the first term minus the first term times the ratio to the 8th over 1 minus the ratio. So just a plug and chug right into this formula. We know our first term is 2. We know our ratio is 3. And the problem tells us that n is 8. Now, make this 1 minus 3. Just make that negative 2. Get that subtracted before we start. Then 2 minus 2 times 3 to the 8th equals, don't forget the equals, divided by negative 2. 6,560 is the answer to that question. All right. Number 3, find the limits. So we're going to find the limit of all these things. Basically, you guys, there are two kinds of problems that we have looked at. We've looked at problems like A. Those should be n's, not x's. That's my fault. So we've looked at problems like that one. This one is the same kind of thing. Again, those x's should be n's. I've mixed my variables, which is not good. Okay, so those two are the only two of that kind. So we've looked at problems that involve numbers being raised to a power. And we've discussed that when we do this problem, what matters to us is the size of this number right here. If the number is less than 1, the limit is 0. These terms are going to continue to get smaller and smaller and smaller as you multiply by 2/3. On the other hand, these are going to continue to get bigger and bigger and bigger as you multiply by 3/2. So this is divergent or no limit. Okay? So that's it. For problems that are a number raised to a power, that's it. Now, the rest of the problems are all n's over n's. So when we have n's over n's, we know, it's just like our horizontal asymptotes, we compare the n's on top to the n's on the bottom. So right here, doesn't matter what order they're in, I've got a negative 2n over a 3n, so that means my limit, or my horizontal asymptote if I'm graphing it, my limit is going to be at negative 2/3. Now, this is exactly the same scenario, but the issue is that's n squared. And when I do this process, this limiting, I have to look at the highest power that I have, which is n squared. So I can't compare an n squared and an n, so I need to put an n squared on the bottom, and since there aren't any down there, I have to make it a 0 n squareds. So now when I compare those two things, I have negative 2 over 0, which we know doesn't exist, so that's divergent. There's no limit. Don't say undefined. This fraction is undefined, but your job is to find the limit. So you're either going to write no limit or you're going to write divergent. All right, E is the same thing. Oops. E is the same thing, only now the missing n squared is up here on the top. Well, that makes all the difference in the world, because now when you compare, you get 0 over 3, which is 0. So this one has a limit, and its limit is 0. And then F, I'm not even going to write down, because we've done these already. We have 6n squared over 7n squared, so the limit in F is 6/7. 6 over 7. 6n squared over 7n squared. Oops. All right, so now we are going to find an explicit rule. Now, when we find an explicit rule, and you just have to remember this, we're finding a rule for the term. So we're going to use one of these two formulas right here always for the explicit rule. We're finding a term, an explicit rule for the term of the sequence. So in problem 4, the sequence is going down by 3s, for A, I mean. It's going down by 3, so it's arithmetic, and the common difference is negative 3. So I'm going to use my arithmetic formula, and I'm going to plug in this and this only. Those are the only two things I know. If all I have is the sequence sitting in front of me, the only parts of the formula that I know is the first term and the common difference. So A sub n equals 32 plus negative 3 times n minus 1. That is the explicit rule. Now I clean it up if I can, and I can. This is 32 minus 3n plus 3. So 35 minus 3n, that is my explicit rule. That is my explicit rule for the sequence in problem 4A. Now, 4B is exactly the same, except, of course, the sequence is geometric, so it has a ratio of 4. I'm multiplying by 4, which means I will use this formula right here. And I will plug in the only parts of the formula that I know right now, given this. I know the first term is 2, and I know the ratio is 4. So A sub n equals 2 times 4 to the n minus 1. I put 2 in here, 4 in here, and I am done. And this one does not simplify. You stop right here. That is your explicit rule. Don't do anything else to it. Never. Do not ever multiply these two. This is it. You are done. That's the explicit rule. All right, we're almost done. A couple more to go. All right, so number 5 says, got an arithmetic sequence in the fifth term. 1, 2, 3, 4. Fifth term is 22. 6, 7, 8. 9, 10, 11th term is 46. So make sure I counted right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so that's what I know. I know the sequence is arithmetic. I know the fifth term in the list, and I know the 11th term in the list. And my job is to find the first term. There it is right there. That's the first term. And somewhere out here, I want to find the 21st term, or excuse me, the 200th term, sorry, the 200th term. Now, you got to figure this out. It's all logic. There are lots of ways to do it. So I'm going to walk you through it the way my brain works on it, but your brain may work on it a different way, and that's okay. Let's look at how I'm thinking about it. I know that I have to get, in this sequence, from 22 to 46. I somehow have to get from 22 to 46. I know that that distance is 24. 46 minus 22. That distance is 24. I know that to accomplish that, I am going to be adding the same number over and over and over again, because it tells me in the problem it's arithmetic. So I am going to have a number, and I am going to add it once, twice, 3, 4, 5, 6 times. I'm going to add the same number 1, 2, 3, 4, 5, 6 times. I have to cover 24 units, and I have to take 6 steps to do it. So each step is going to have to be 4. I am going to add 4, add 4, add 4, add 4, add 4, add 4. So my common difference is 4. And again, I figured that out by taking the total distance I had to cover and dividing it by the number of steps I was taking. Now, I need the first term. Well, that's going to be easy to find, because if I get here to here to here to here by adding 4, then to go backwards, I'm going to be subtracting 4. So 18, 14, 10, 6. So the first term is 6. That was the first question, find the first term. Now I need the 200th term. Well, I could keep adding 4, but that would take forever. So I am going to come over here, and I'm going to use my arithmetic A sub, my arithmetic formula, to find the 200th term. So I know the first term is 6. I know the ratio, or excuse me, the difference is 4. The common difference is 4. And since n is 200, this is going to be 199. So the 200th term of that sequence is 802. Done. And again, I don't know what kind of steps you're going to go through in your own mind to solve that, but you better come up with 802 as the answer. All right, and finally, the very last problem, we're going to change the repeating decimal 0.32 into a fraction in lowest terms. Now, guys, listen. You got to show some work. I want you to show some work. what does this fraction look like if I, or this decimal, what does this decimal look like if I wrote it out? Well, 0.3222222 dot 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 dot. And what does that dot 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 mean? That dot 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 means it goes on forever and ever, infinitely. So the only formula up here that could possibly apply is this one, because this is my infinite geometric series formula. This is the only one that doesn't have an n in it. Every other formula has an n in it. Okay? So I'm going to be using that formula. So what does that formula require me to know? Well, I need to know the first term of the repeating part of the decimal. Now, this is a trickier one than the one we did last time, because this actually has an extra number in it. The 3.3 is not a part of the repeating. The first part that repeats is this guy right here. He's the first repeating part. So if we think of this as a sum, we have 0.3 plus 0.02. Got to disregard him. He isn't part of the repeating. And then we have 0.002, 0.002, and so on. So the first part of the repeating, that's all the formula can handle. You have to be a sequence. The first part of the repeating is 0.02. So there's the first term. Now, what's my ratio? We've talked about this over and over. If you have one decimal place repeating, one number repeating, which is what's happening here, there is one number repeating, then your ratio is 0.1. Period. Each term is moving one decimal place, 0.1. So 0.02, what is 1 minus 0.1? Well, 1 minus 0.1 is 0.9. Now, I need to make that a fraction, which it is a fraction, but I gotta get rid of the decimals. So I'm gonna move this decimal 2 places to give me a plain 2. But if I move that one 2 places, I have to move this one 2 places, which will give me not a 9, but a 90. So 2 over 90. Not done. This problem is tricky, because this is the fraction, and I know it's not reduced, we'll get that in a second. This is the fraction for the repeating part of the decimal. Remember, we still have this extra 0.3, 3/10, that isn't part of the repeating decimal. So we have to take the 2/90ths that we got and add on the 3/10, because it's part of the problem. So we'll get a common denominator. It's really easy. It will always be easy to get a common denominator here. You'll never have to do a bunch of hard work. So my denominator is going to be 90, and my numerator is 2 plus 27, 29. And then I always do a quick double check on my calculator. If I do 29 divided by 90, I should get my original decimal, which I do. So when we take our quiz, this is the kind of work I need to see. I don't necessarily need to see this all written out, although maybe you will, because it might help you. But I need to see you using your formula. I need to see you adding on that extra piece and coming up with your answer. All right, that's it. Good luck.